Video 4, asymptotes. We're going to look back at the example of the function f of x equals 1 over x subtract 5. Now we had to restrict the domain because we couldn't divide by 0. So this restriction on the domain for this function was that x is not equal to 5, because if it were, then we don't have a value for the function. So f of 5 doesn't exist, can't do that. This means there's an asymptote when x equals 5. We can draw this graph. The graph looks similar to the picture of 1 over x on page 13. Except the asymptote we'll put in where x equals 5 here. We can make a dotted line up and down to represent the asymptote in the shape of the graph, similar to 1 over x. F of x or y on this axis. So this is the graph of f of x equals 1 over x subtract 5. So the asymptote is somewhere where the graph gets closer and closer. Here it gets closer and closer to 5, but doesn't actually touch x equals 5. That's a vertical asymptote. When x equals 5. X equals 5 is the equation of the vertical asymptote. And the vertical asymptote will occur when the denominator is 0. So our denominator was x subtract 5. So when x subtract 5 is 0, that means x equals 5 as the equation of the vertical asymptote. Now this graph also has horizontal asymptotes, and that's when x gets greater, it's approaching the x-axis but not actually touching. Also, the negative side is approaching. Now I've drawn that to touch. That doesn't actually touch at any stage, it just gets closer and closer. So in this example, you've got a horizontal asymptote as well. As the x-axis. So that equation is y equals 0. We're going to look at example 2 on page 16. The function is f of x equals 3 subtract 4 over x squared. So we have a problem when we divide by 0. So since this is a fraction with x on the denominator, we've got a problem when x squared equals 0. Take the square root of 0, it's still 0. So when x is 0, the function doesn't exist. So we need to restrict the domain of this function. X can be any real number, but x cannot be equal to 0, because then the function wouldn't exist. So that means there's an asymptote, a vertical asymptote, when x is 0. There's also going to be a horizontal asymptote. We need to find that. We can do this by imagining what happens as x tends to infinity, or gets larger and larger, and also what happens when x tends to negative infinity. So if x tends to infinity, what happens to our function f of x equals 3 subtract 4 over x squared? Well, this part, 4 over x squared, is going to get smaller, because the number we're dividing by gets bigger and bigger. So we say that 4 over x squared tends to 0 as x tends to infinity. This means all we're left with is this number 3. So f of x equals 3 as x gets larger or tends to infinity. The same happens when x tends to negative infinity. F of x equals 3 subtract 4 over x squared. So this part here gets smaller and smaller, and f of x equals 3 when x tends to negative infinity. So y equals 3, or f of x equals 3. This is our horizontal asymptote. Y equals 3, or we can say f of x equals 3, as f of x represents the y-axis.